So in this third video covering activity 5.7 and 5.8, we start to examine the multiplication property of radicals. So if we look at it in symbols, if we have the square root of a times the square root of b, we can say that's equal to the square root of a times b. And they give us an example here. All right, so the numbers that are under the square root sign are the 3 and the 2. So we can rewrite this as 2 times the square root of 3 times 2. And we know 3 times 2 is 6, so we end up with 2 times the square root of 6. All right, so 2 times the square root of 3 times the square root of 2 is the same thing as saying 2 times the square root of 6, or 2 radical 6. Okay, so now when we look at the multiplication property of radicals, we can also reverse it, right? Here we have the square root of a times the square root of b equals the square root of ab. Down here, you'll notice we're going in reverse. The square root of ab can be broken up to read the square root of a times the square root of b. So if you look at example 3, we have the square root of 20. Notice how they rewrite that as the square root of 4 times 5. And then they can break up square root of 4 times the square root of 5. And we know that the square root of 4 is actually 2. Okay, so the final answer is 2 times the square root of 5. All right, so if I ask you to simplify the square root of 20, your final answer would be 2 times the square root of 5. Right, again, we break 20 into factors, 4 times 5. And then the factor 4, well, we can write that as the square root of 4 times the square root of 5, which is equal to 2 times the square root of 5. Right, and that's our final answer. Right. If you look at example 4, we have 12 times x squared times y cubed. Again, we can use the multiplication property in reverse and rewrite this as 12, the square root of 12, times the square root of x squared, times the square root of y cubed. And then notice how they break the square root of 12 into the square root of 4 times the square 3. X squared, and the y cubed gets rewritten as the square root of y squared times y. And then we continue to break these down even further. Right? The square root of 4 we know is 2. The square root of x squared is x. The square root of y squared is y. So the 2, the x, and the y are outside of the radical sign. And the only thing that's inside the radical sign is the square root of 3 and the square root of y for my final answer. All right, so let's practice a few of these, and I think you'll understand a little bit better with a little bit of practice. Okay, so for problem 1, it says multiply, right? So really, we're just going to write this as the square root of 2 times 5, final answer, square root of 10. Right, if I look at number 2, right, again, this is the square root of 3 times 7, or the square root of 21. Right, if I jump to number 4, this is going to be the square root of 3 times 10, which equals the square root of 30. And you can quickly see, right, the square root of 55. All right, now this number 5 is a little trickier. This can become 2 times the square root of 7 times 5, right? The 2 is not inside the radical sign. So you're left with 2 times the square root of 35 as your final answer. Okay, let's keep going. If I look at number 6, right, the 4 is on the outside. So I'm going to write 4 times the square root of 6 times 7, or 4 times the square root of 42. Okay. Number 7, okay, the 2 is on the outside, stays where it is. Everything else we can bring underneath the radical sign. Okay. Number 8, same thing. The 5 is on the outside. Everything else will come inside. So we're done with numbers 1 through 8. Let's take a look at problems 9 through 18. So here we're asked to simplify as much as possible. So for number 9, I'm going to write, we can break this up into 9 times 2, which is the same as square root of 9 times the square root of 2. And we know that the square root of 9 is 3. So that would be my final answer. Okay. Now, I want to show you something. What if you didn't use 9 and 2? What if you used the numbers 6 and 3? Right, so if I were to break this up into the square root of 6 times 3, right, and actually write out square root of 6 times the square root of 3, right, what happens is we can break the square root of 6 down further to get square root of 2 times the square root of 3 times the square root of 3. And then if you take a look, the square root of 3 times the square root of 3, that actually equals 3. Right? Because think of it this way, the square root of 2 times the square root of 9, right? 3 times 3 is 9. This ends up being 3, right? So we end up with 3 times 2, right? 3 rad 2, right? So it's easier to go, if you can find a perfect square as one of your factors, right? So my factors, in this case, we use 9 and 2. 9's a perfect square, meaning I could take the square root of 9 evenly. So it's better to take a perfect square as one of your factors because there'll be fewer steps to finish the problem. When we use 6 and 3 as our factors, 6 and 3 neither are perfect squares, so I had to break the 6 down further to get square root of 2 times the square root of 3 times the square root of 3. And now the square root of 3 times the square root of 3 is 3. Right? Square root of 3 times the square root of 3 is the same as the square root of 9, which becomes 3. So you end up with the square root of 2 times 3, or 3 times the square root of 2. All right, so it doesn't matter how you get to here, but we need to end up here. Okay? Let's do problem 10. I'm going to erase some of this work just to make more room. So for problem 10, we can write this as the square root of 4 times the square root of 7. And the square root of 4 we know is 2, so we end up with 2 times the square root of 7. Now, what would happen if you said, Mike, couldn't we write the square root of 28 as the square root of 2 times the square root of 14? I would say, yes, you could. But that then would become the square root of 2 times the square root of 2 times the square root of 7, right? Because 14 breaks down to 2 times 7. And now the square root of 2 times the square root of 2 is the same thing as the square root of 4, which becomes 2. And then the square root of 7 comes down. Right? So we end up with the same answer no matter how you do it. Right? So it's better if you can find the perfect square. In this case, the square root of 4, right? 4 is a perfect square. Right? If you look at number 11, I would use 16 as the perfect square. Right? 16 times 5 is 80. The square root of 16 is 4. There's my final answer. And for number 12, the square root of 72 becomes the square root of 36 times 2, or the square root of 2, and you're left with 6 times the square root of 2. Okay? Let's keep going. 13. Number 13 can be broken down as the square root of x squared times the square root of x, and the square root of x squared is x. That's my final answer. Right? Number 14, we can write this as the square root of y to the 4th times the square root of just y. And the square root of y to the 4th becomes y squared times the square root of y. It's my final answer. Right? Number 16 is similar. This is going to be x to the 6th times the square root of x. Right? And the square root of x to the 6th becomes x cubed. And that's my final answer. Okay? Number 17. Well, actually, let's do 15 first. Number 15, that's really just going to be w to the 5th. Right? The square root of w to the 10 would be w to the 5th. 17, we can break everything down. I can write this as the square root of 4 times the square root of 3, right? That's the 12, times the square root of a to the 4th times the square root of a, right? Because a to the 4th times a is a to the 5th. Now the square root of 4 is 2. The square root of 3 I cannot do anything with. The square root of a to the 4th becomes a squared, and the square root of a remains square root of a. So I'll put the a squared and the 2 together, so that's 2a squared, and everything that's on the radical sign, 3a. That's my final answer. Okay. Number 18, we can break this down to the square root of 9 times the square root of 3. That gives me the 27, right, times the square root of a times the square root of b to the 6th times the square root of b. Now the square root of 9 becomes 3, so we have 3 square roots of 3 times the square root of a. The square root of b to the 6th is b cubed times the square root of b. And let's put everything together to get 3b cubed. And then under the radical sign, we have 3ab. Make that a little better. Okay, and that's my final answer. All right, so in the next video, we'll finish up with solving radical equations. Okay.